Okay, welcome to our next lecture, I guess, or voiceover PowerPoint in this series. We're going to start talking about central tendency. So I want to bring your attention to this file called Big Picture. It's under Meeting 1, the material. This is our roadmap for the course. And so we've laid a little bit of foundation in the previous PowerPoints. And so now we're kind of getting into the meat of the course. As you know, this is a quantitative course, so we're definitely in quantitative world. As I mentioned in that very first PowerPoint, we are talking about descriptive statistics and then inferential statistics. And so what we'll do is we'll spend a little less than half, I guess, but a little more than a third, so whatever that would be. We're going to spend that time on descriptive statistics because remember, like I said earlier, you really want to describe your data to your reader and really for yourself so you can get an idea of kind of what's going on with your participants or data or whatever you're dealing with. And then we're going to move into inferential world toward the second part of this course and then all the way through next semester. All right, so first, when we're talking about describing our data, we'll talk in this lesson about central tendency, measures of spread outness or variability, measures of distributional shape, and then measures of relationship. So I'm going to refer back to this or refer to this big picture pretty frequently because like I said, it's sort of our roadmap, keeps us on track of where we're going from the beginning to the end and kind of where, because I think it can be easy to get lost sort of in the parts and pieces as we're going through them. So I want us to keep coming back to this sort of bird's eye view of what we're doing. So we're still talking about describing our data. And today, or in this one, we're going to talk about central tendency, okay? All right, so starting central tendency, like I said, we're still in descriptive world. We're still wanting to summarize large sets of data and help us make sense of the data. And it allows us to better understand what's going on with our data. First us as a researcher, and then what we want to relay to our readers. Okay, so like I said, those 4 classes of descriptive statistics, I'm not going to read through them again, but in this video, we're talking about central tendency. Okay, so we have 3 measures of central tendency. So what I want you to do when we're talking about central tendency is just continue to come back to the idea that central tendency is the best measure, the best number that represents all of your data. So throughout this course and next semester, I'm going to use the word distribution a lot. So a distribution is just a set of scores. So if you want to think a classroom set of scores, a school set of scores, a state set of scores, whatever that set of scores is, maybe age or height or weight or BMI or IQ or test scores, or depression scores, or whatever they are. You may be super depressed after this video. Whatever that is, when we look at that set of, say, age scores, that's a distribution. So a distribution is just a set of scores. So we want to find the one score that best represents our distribution, right? The one age that best represents our whole class of people's age, all right? Our first option, and kind of the most basic, is the mode. The mode, as you probably know, is the most frequently occurring score. It's really easy to calculate, and we don't really have to calculate. We have to sort of identify it, right? But it does have some disadvantages. So taking into account the majority of the scores, what happens when the scores are spread out, does it take into account all the scores? So let's look at an example. So I'm going to see if I can get my wonderful little pen to work here. I'm going to go there. Okay. So think about this number line. Ooh, that's super crooked. Maybe I have 100 in the middle. 4. And I have 130 over here, and then 70 over here. All right, so it's starting to look suspiciously like IQ scores, right? Okay, so what if I had one score of 70, 2 for 100, and then 1 for 130? All right. What would the mode be for this distribution? All right, the most frequently occurring score would be 100. All right. Let's consider a second distribution. So what if we had 100 again, 115, and then 85? And I had, let's say, still 2 people at 100, but now my other person is here and my other person is here. All right, what would my mode be for this distribution? Mode would also be 100. All right, so let's think about it in terms of these disadvantages. Does the mode take into account the majority of scores? Well, it takes into account the most frequently occurring scores, but it's really totally ignoring these other scores. So if I'm looking at the one number that best represents my whole distribution, because, remember, my distribution, that's my set of scores. So I have that 70, see if I can get this to work. Oh, I guess I have to be down here on the thing. 100, 100, and 130. All right, so I'm saying that 100 is the best representation of all these scores. Well, it does a pretty good job of capturing these two in the middle, right? Because it is 100. But it doesn't do a very good job of capturing 130 or 70, or representing 130 or 70. Okay, so it does not take into account the majority of scores. What happens when the scores are spread out? All right, so let's pretend this is a couple of groups. Maybe we'll call this group A. That's terrible. And group B. All right, so maybe these are tutoring groups. And your supervisor comes to you and says, I want you to tutor group A. They have a mode of 100. Or group B. They have a mode of 100. But they don't show you the individual scores, right? You can choose from a mode of 100 or a mode of 100. Which would you like? But you can see that, and if you treat these as people, this group is much more heterogeneous than this group. So depending on what you're teaching, this group that's more similar may be easier to teach, right? Because these are IQ scores, it looks like. So if you have a small group and the IQ scores or the intellect of your group is relatively, similar, of course it's not the same, but it's more similar than, say, this group of students where you have a person with a 70 IQ, a person with a 130, and then 2 people in the middle. Right? So when the scores are spread out, the mode does an even worse job of capturing or representing all of the scores. And does it take into account all the scores? No, we were just talking about that. So the mode, while useful, can be misleading, right? Or it can not provide us enough information. Okay, so let's look at it a little further. For the level of scale, you need to have at least, let me turn my pen back on, yay for the spin. You need to have at least nominal data. So if you have nominal data, the problem is if I put my hand down on this little pad, it does weird stuff. So if you have nominal data, like you have, I always use a gender, don't I? So I'm going to say treatment and control. So if I have my treatment people labeled as 2s and my control people labeled as 0s, haha, see, I tricked you up a little bit. I can talk about the mode of these categories. All right, so the most frequently occurring category is going to be my 0s or my control group. All right, I need to have at least at nominal level data to calculate a mode. Now, let me draw this little example for you. I want to ask you a question. All right, so say this is 50, 60, 70, 40, 30. All right, and then what if I have one person at each? Gee, these little stars represent people. That's very creative, I know. You're jealous. All right. And here, and here, and here, and here. Okay, so here's your distribution. I plotted it for you on this number line. So what would the mode be of this distribution? All right, what's the most frequently occurring score? Well, it's going to be 70. All right, so before we go any further, let's think about that. If this is the most, the one value, remember central tendency is the one number that best represents all of our scores. All right, so 70 is representing 70 really well, but it's not doing so great for all of these others, right? 60 is not too bad, but 50, 40, 30, all these people over here, they are not really being represented. So maybe this was an evaluation of how many laps a person could run in a semester. All right, so you have to report this information and you say, well, the mode of all my students is 70. And your supervisor is thinking, wow, you are an awesome coach, right? Because they're thinking 70 is a good representation of all your students. It's really good for 3 of your students, but not so good for these other students, right? And so the mode can be a little misleading. All right, so what if I have another person join us and they are added here at the 50? All right, so now what's the mode? Yeah, so it has 2 modes. So we call that, I'm not going to be able to write it very well, but it's bimodal. That's a 0 and that's a D. Okay, bimodal. All right, so what if another person comes and it's 40? So now what's the mode? What would we call that? I mean, trimodal would make a lot of sense. So you know it can't be that because this stuff rarely makes sense, right? So once we surpass 2 modes, then we just say there's no mode. Because remember, if we're thinking, all right, the mode is the one number that best represents the distribution, now we don't really have one. It's almost like they give you bimode, okay, you might have 2 numbers, but anything beyond that, we just say there's no mode. Okay? All right, let's go on down. Because of the difficulties with the mode, the fact that it doesn't take into account all the scores, it's not very representative of all the scores, and it doesn't represent, in certain situations, it represents all the scores even worse. We have another statistic that helps us, and that is the median. Okay, so we're still after that one number that best represents our entire distribution. Okay, so our next attempt at finding that value is going to be the median, and the median is the point in the distribution that divides the distribution into 2 equal parts. So the median may not be a scored score. But the mode will always be a scored score. The median does have a formula, but we're not going to use it. We are going to either eyeball it or we're going to use SPSS because we're not going to pull out that formula. All right, so let me show you a couple of distributions, a couple of examples, and let's talk about them for a second. So if I'm looking at this distribution, I actually didn't even need a number line. So if I have a 70, a 71, a 72, a 73, and a 74, since I drew it, I'll continue to draw it. All right, so what would my median? In median, we can abbreviate. You might see it MDN sometimes. All right, so what would be the median here? the point in a distribution that divides the distribution into two equal parts. All right, it's going to be 72, right? Because if it's 72, I'll have 2 over here and 2 over here. All right, so let's look at the next little distribution. 11, 12, 13, 14. Okay, so what would my median be here? In this case, it's going to come right in between these two. So it would be 12.5. All right, so that's an illustration of this. Okay, so up here, the median was an actual score in our distribution. Okay, maybe these are all the ages of the grandparents in my children's lives, right? So 72 is an actual age of one of the grandparents. But maybe down here, these are the ages of all the cousins. But in this case, the median is not an actual age, which is 12.5. So the median may not be a scored score, but it might. Whereas the mode will always be a scored score. Okay? All right, so let's look a little bit more about the median. The median is always at the 50th percentile. The median tends to be away from the extremes, only takes into account the magnitude of the middle score, and we need at least ordinal data to determine the median. All right, so let's look at one of these problems of the median. Oops, I have my pen upside down. Okay, so the median, if I'm looking at, let's look at just a little tiny data set. So how about 3, 4, and 999? All right, so what is my median in this one? It's going to be 4. All right, now let's look at another little tiny set of data. 2, 4, 6. What's my median? Oops, median. It's median, people. Also 4, right? Okay, so I have 2 identical medians that really, this median does a pretty good job of representing all the scores. Can you see that? But this median of 4 doesn't do a good job of representing 999. So the median tends to be away from extremes. Now this is an extreme example of that. It only takes into account the magnitude of the middle score. So whether it's a good representation or a bad representation of all the scores, it really only cares about itself. Oh, it's kind of selfish, isn't it? The median is a little bit selfish. Okay, so it only takes into account the magnitude of the middle score. It really doesn't care what's going on either side of it. And we need at least ordinal data in order to determine the median. So if I have my categories again, my treatment and control. So say I do have my 1, 2, 3 treatment people and I think I had 4 control people. Now this is treatment and control. Before I could identify the mode, which was control or 0, right? But I cannot line these up and say that, what would that be? I cannot line these up from smallest to biggest and say that this is the median, right? So that's a no. We have to have at least ordinal data to determine the median. We cannot, so I'll say no median for categories. Now, I'll tell you what, I get it every semester. Every semester, when you guys start calculating stuff, I will get the mode and the median for, well, the mode is okay, but I'll get the median for your categories. And in fact, I'll even get the mean for your categories. It happens every time. I think it's just a matter of forgetting to unclick some stuff. And then, if you don't go through your output and really think about it, you'll miss some things like that. So median has some problems. Okay, the mode had problems. By problems, I mean not being the best representation of all the data. The median also has some problems. Doesn't take into account that what goes on either side of it. It's our little selfish statistic. So there is another statistic we can look at, and that is the mean. That is the mean. We're going to try to fix as much of those issues with the mean as we can. All right, so here are your formulas for the sample mean and the population mean. So the sample mean is what I showed you earlier, right, in that earlier PowerPoint. The population mean is the same, except for the symbol now becomes mu and the N becomes capitalized. So a capital N means the number in the population. The lowercase n italicized is the number in the sample, in that particular sample you're dealing with, okay? So X bar is the mean, sample mean, and mu is the population mean. For what we're going to talk about for this first part of this course, we're just going to kind of ignore this population mean. We're only going to talk about the sample mean, all right? So, and like I told you before, it's just the average, right? It's the sum of all your values, so all of your distribution summed together, divided by the number in your distribution, okay? All right, we have to have, like we talked about before, at least interval data to calculate a meaningful mean. Mathematical operations require an equal interval. And the mean, again, is a conceptual balance point of a distribution. It is going to be the best representation of all your values in your distribution. A lot of times, not always. In some cases, and we had this discussion in class, in some cases the mode is best to know, and sometimes the median is best to know depending on the situation. So don't rule out the mode and the median. So imagine that you are a shoe salesman and you're in charge of ordering inventory. You can probably imagine how having the mode of your sales, as far as the size and the type and all that, would help you build up your inventory. So the mode in that kind of a case would be valuable. The median can come into play. I know we hear a lot about it on the news as far as home prices go. They want to report the median home price because those really high-end homes can make it seem like most people in that area make more money than they do. Because if we calculate the average, it could really skew the average to the upper side of home prices, when really that's not representative of what most people are spending for a house in that area. So sometimes the median is the best representation, but a lot of times it's the mean, okay? So just think about it being the conceptual balance point, so we're going to look at it in terms of the formula. But for these next few things, first I want you to just think and then calculate, all right? So, oops, I didn't turn my pen on. I guess I got it too far away from my board, and so it quit working. I got to get a better system. Okay, so here we go. Think about this. If I have 2, 3, 4, 5, 6, 7, 8. Ooh, that's not very spaced. Y'all have to use your imagination, okay? 4, 5, 6, 7, 8. All right, and what if I have a 3, a 4, 2 5s, and a 6. All right, so I want you, before you do any math, I want you to try to imagine what is the conceptual balance point of this distribution. All right, think seesaw. If you're going to put that fulcrum somewhere so that one side of kids wouldn't bump to the ground, remember that when you hurt your tailbone in elementary school, when that person would get off and you slam to the ground? Well, we don't want that to happen to our numbers up here, or digits up here. So go ahead and figure out, where would you put that fulcrum so that it would balance? Would it be over here between the 5 and the 6? Would it be between the 3 and the 4? Would it be between the 4 and the 5? And then just kind of try to figure that out. All right, make some guesses. And I usually get quite a few guesses. So I'm going to do a real typical guess I would get from students since I can't hear you. I'm going to say 4.8. A lot of people guess that it's going to be somewhere right here for that balance point. Okay? So let's figure it out now. Let's use our super fancy formula and figure it out. So I'm going to say 3 plus 4 plus 5. Now here we go. Don't forget your other 5 because that's a real common mistake. 5 and a 6. And I'm going to divide by how many scores I have. I have 1, 2, 3, 4, 5. So that is going to equal 23 divided by 5, which equals 4.6. So that mean is 4.6. So 4.6 then is the best representation of all your data. And it does a fairly good job. At 4.6, all of our data is equally distributed around this mean. Okay? 4.6. All right, let's do another one. We'll just do one more. Remember, I want you to eyeball it first, and then let's do the math. So let's do 5, 6, 7. 5, 6, 7. And I have 2 5s. 1 6 and 1 7. All right, so I'm looking for the mean. I'm looking for your guesses. All right, so remember, think seesaw, no bouncing butts on the ground. All right, where would you put that fulcrum? Okay, a real common guess I get is about 5.5. So when you're eyeballing it and you think, all right, if I put that fulcrum right about there, well, that's a terrible line, right in the middle, it's going to balance these 2 sitting on 5 and then the 6 and the 7. It's about 5.5. All right, so let's calculate it mathematically. So again, 5, don't forget your other 5. 5, 5 plus 6 plus 7. Oh, that's terrible. I hope y'all can read that. Divided by this time 4. So our mean becomes, again, ironically, or coincidentally, I should say, 23 divided by 4, which equals 5.75. All right. So it was not too far from our guess. It's just a little bit off right here. Okay. All right. So again, conceptually and then mathematically, because I want you to kind of get it nailed down that it's the conceptual balance point of a distribution. The mean is usually the best. It is usually the one value that best represents the distribution. So we're going to use the mean a lot. All right, this is a very long PowerPoint. I hope that I can upload this somewhere so that you guys can actually watch it. All right, see you next time. Or I won't really see you, will I? You will hear me next time.